Assalamu alaikum and welcome, my dear followers, subscribers, students, colleagues, ladies and gentlemen. Today I'm starting a new series of lectures in a separate playlist known as Introduction to Game Theory. There will be a series of lectures in this playlist, but this is for the beginners, those who don't understand the game theory. So these are just introductory type of lectures. The game theory was first applied in economics by John Newman and Morgenstern in the theory of games and economic behavior. And this book was published by Princeton University Press in 1944. As far as Newman is concerned, Newman was born in 1903 and he died in 1956, and he was a mathematician at the Institute of Advanced Study in Princeton, whereas Morgenstern was born in 1902 and he died in 1977, and he was an economist at Princeton University as well. So both of these gentlemen, that is Newman and Morgenstern, belong to Princeton University. Newman invented game theory in 1928 when he proved his famous mini-max theorem. As we know that economics is about decision making. However, decision problems come in different styles and colors. For example, a decision problem may occur in a world where there are complete information and certainty, and then there are decision making which needs to be done in case of incomplete and imperfect information and uncertainty. So there are those problems where decision makers are asked to make choices in a world of perfect and complete information and certainty. For example, consumer theory and producer theory that we discussed in earlier videos in another playlist. These were type of decision makers who are working under perfect and complete information and certainty. Then there are those choices which are made when there is uncertainty and where the decision makers are uncertain about some aspect of the world they are in, but they know the probabilities with which various events can occur. This is like a game against nature, where we are playing an opponent who is indifferent to our welfare but who simply acts randomly in a prescribed manner. Our task here is to choose optimally, stringent upon or condition upon random nature of our opponent. Finally, there are games of strategy. In games of strategy, we are in a decision making problem under uncertainty. But uncertainty involves the action of a real, live opponent who is out to maximize his or her payoff and who may or may not care about your welfare or our welfare. So, in these situations, we cannot act optimally until we make a conjecture about what our opponents are likely to do, and they must make a conjecture about not only what we are likely to do, but what we think they are likely to do, etc., etc. So the central question of games of strategy is, I think that he thinks that I think. The process will end. Game theory allows us to describe and analyze social and economic situations as if they were games of strategy. We will therefore begin this lecture by defining what a game of strategy is what a game is, what are the various elements of the game, and then we will discuss how we would expect any such game to be played by rational economic agents. We'll find the game theory makes it possible to predict the equilibria for games, those states in which no player will want to change her behavior given the behavior of the other players in the game. So what do we mean by a game of strategy? In this case, a person is engaged in a game of strategy with someone else or with several other people when his or her utility or payoffs is affected not only by the actions that he or she takes but also by actions that his or her opponents take. So this is what we mean by a game of strategy. Two parties are involved and their strategic actions are interdependent, and then there are certain outcomes. For example, chess is obviously a game strategy because whether a player wins, loses, or draws depends not only on his choices but also on those of his or her opponent. Many economic situations can also be viewed as game of strategy. For example, the profits of a car company like Toyota depend not only on its own pricing decision but also on the pricing decision of its competitors including Honda, Hyundai, Suzuki, Nissan, Kia, etc. etc. Similarly, political conflicts often have characteristics of games of strategy. More simply, a game of strategy is a multi-person decision problem in which an abstract set of rules constrains the behavior of players and defines outcomes on the basis of the actions taken by the players. Under this interpretation, the game is the rules, and in order to have a well-defined game of strategy, we must have a well-defined set of rules constraining people's action. Now, a question is, what do we mean by a game? Any situation, game is any situation in which individuals must make strategic choices and in which the final outcome will depend on what each person chooses to do can be viewed as a game. A game is an abstract model of a strategic situation. All games have at least three basic elements. Number one, players. Number two, strategies. And number three, payoffs. So we will explain all these three elements in a bit more detail. In complicated settings, it is sometimes also necessary to specify additional elements such as the sequence of moves and the information that players have when they move to describe the game fully. Now let us discuss what do we mean by players in case of a game. Each decision maker in a game is called a player. These players may be individuals, for example in a poker game. They may be firms, like in market with a few firms, or entire nation as in military conflicts. A player is characterized as having the ability to choose from among a set of possible actions. There are a number of strategies, and he is expected to follow or pursue or conduct or do particular strategy. Games are sometimes characterized by the number of players involved. Games may be two-player, it may include three players, or they may be n-player games. Here we focus on two-player games because this is the simplest strategic setting. We will label the players with numbers. Thus, in a two-player game, we will have player 1 and player 2. In an n-player game, we will have players 1, 2 up to n with the generic player labeled I. Then we have strategies. The second element or the second basic element of the game is strategy. Each course of action open to a player during the game is called a strategy. Now, depending upon the game, a strategy may be a simple action or a complex plan of action that may be contingent on earlier play in the game. Many aspects of game theory can be explained in games in which players choose between just two possible actions. Let us suppose S1 denote the set of strategies open to player 1 and S2 be the set of strategies open to player 2, and more generally SI is the set of strategies open to ith player. Let SI be member of the capital SI and it is a particular strategy chosen by player 1 from the set of possibilities. So capital S1 is the set of possibilities and the small s1 is a particular strategy chosen by player 1. Similarly, this small s2 belongs to player 2, so this is a particular strategy out of the possibilities, out of the set of the possibilities chosen by player 2. And similarly, SI is a particular strategy chosen among all possibilities by ith player. A strategy profile will refer to a listing of particular strategies chosen by each of a group of players. The third basic element of the game is payoffs. The final return to each player at the conclusion of the game is called a payoff. Payoffs are measured as levels of utilities obtained by the players. Sometimes monetary payoffs are often used, say profits for firms in a market situation. Generally, payoffs can incorporate non-monetary factors including prestige, emotion, risk preferences, and so forth. In a two-player game, U1 of S1, S2 denotes player 1's payoff given that he or she chooses S1 and the other player chooses S2, and similarly U2 shows the payoff or the level of utility of player 2 which who takes a strategy S2 when the player 1 takes strategy S1. The fact that player 1's payoff may depend on player 2's strategy and vice versa is where the strategic interdependence show up, and that is why we have game of strategy. So in game theory, this strategic interdependence is very important because this stems from the fact that each player's payoff depend on the other player's strategy, and this is where the strategic interdependence between players come to the surface. In an n-player game, we can write the payoff of a generic player I or ith player as UI, SI, and S sub minus I, which depends on player I's own strategy and the profile S sub minus I, that is equal to S1 up to Si minus 1, Si plus 1 up to Sn, and this profile of the strategies of all players other than, this is the profile of strategies of all players other than ith player. Ladies and gentlemen, these are some of the basic concepts which are used in game theory, and in the following videos I'll explain the simple two-player game involving prisoner dilemma, and then I'll discuss Nash equilibrium and so on. Kindly subscribe to the channel and don't forget to click on the bell icon so that you get